Okay, good. Okay, so what is stack and what is queue? Okay, so these two things are a very, you can say it as a very powerful tool that we are going to use in our where we apply linked lists. So what does stack and queue means? Okay, stack. How do you want to how do what is a good analogy is, you imagine like a tennis ball container. Okay, a tennis ball container where you can only fit one ball at a time. Okay, so what you do, you put in the first ball, which is black, so you put the black ball, and then you put the red ball inside. Oh, this is blue. it, Never mind. So the blue will go inside, and then you put the red ball afterwards, and then the red ball will be on top. When you want to take out the ball from the stack, what will happen? You are going to take out the red ball first, okay, and then the blue ball, and then the black ball, okay. So what does it mean? It basically means if you put the item or the data in a stack first, it will be the last item that you will bring up. Okay. In other words, stack is basically first in, last out, FILO. Okay. How about queue? Queue is a bit different. Basically, queue is, uh, you can say it like you are going to queue for a ticket, to buy a ticket, right? So you go to a counter, you see many people are queuing, right? So so this is you. You are waiting here. You just came in. So you see there are 4 people in front of you and 1 person at the back of you. So when you want to buy the ticket, you have to wait the 4 person that came first, and then it's your turn. You are not going to wait for the last person who came in. No, you are waiting for the 4 person in front of you to buy the ticket first, and then you will take the ticket. In other words, when the first person comes in, he is going to be the first person to be served. First come, first serve, or first in, first out. FIFO. That's basically it. The concept. That's all. Nothing else. So that's why I call it as a what do you call it? Short lesson. But let us try to do it practically. Okay, so I've prepared first. Not prepared, I'm just copying what the one from the previous linked list table, and let us try to implement this. Okay, when you are implementing stack and queue, we have there are 2 operations for stacks and 2 operations for queue. For stack, we have push, we have pop. For queue, we have enqueue, enqueue, and dequeue. DQ. Okay? How are you going to basically push and enqueue is you put the item inside the list, inside the stack or inside the queue, where pop and dequeue basically means you are removing the item from the list. Okay? However, what's the difference between push, pop, and enqueue, dequeue is that the way you want to operate. Okay? So for stack, let's say for simplicity, for the sake of we want to make sure everything, we want to optimize our code, we are just going to add the item at the first column, at the header only in our linked list, right? So push and enqueue is basically the same thing. So push and enqueue, same. We push it at one end. When we want to pop, what happens is that the item will be removed from the same end as well. So it comes out from here. Whereas for DQ, it is not coming out from where it comes in. It comes out from the other end. This is DQ. Okay, so that's the difference. So in other words, we can let us do push first. Define push. Okay, push self. Let us put some data here. Okay. So temp equals to, I think there's someone who is asking who's to yes, Adam.
Brother, can you zoom in? The code is too.
Oh, I forgot. Sorry. Thank you for reminding me. I guess this is enough. Okay. So all these nodes are basically the same as before. We have set data, and get next, everything. And for class, we have this one only. Okay. So temp node, or what we can do is we can do it like this. Let me, okay. If self head is none, self head equals node squared data. So we want the self head to hold the data that we are going to hold. Else, self head dot get what do you call it? Set link. Self head dot set link. This is very optimized. Let me just do it. Let me make it under more developer friendly for you guys. Temp node equals to node data. Temp node equals temp node dot set link self dot head, and then self dot head equals temp node, and then we delete the temp node like this. Okay. So for the sake of making it quick, I'm going to put the display. Where's the display list? This one. Okay, I'm just going to copy this. So what will happen? So LL, did I do LL? No, list equals to LL list dot push 10, and then let me just copy it, paste 20, 30. This is basically add to start functionality. So list dot display list. So when we run this, current file, and we will get 30 to 20 to 10. We can also do the same for NQ. So what we can do, since they are both basically the same, NQ self dot comma data, since we already have the same functionality as the push, we can just do it like this. Self dot push data. We reference to another function that have the same function, function that have the same functionality as enqueue. So this is push, this is enqueue. How about pop? Okay, so for pop, define pop. What we can do is that if self hit is none, as usual, self hit, we don't want to do that. We want to return print the list is empty. The list is empty. Else, what we want to do, self hit equals self hit dot get next. Okay, let me just recap again. Get next. Okay, that's all. You can also, to make it easier to understand, I can do it like this. Tab node equals to self hit dot hit. Self hit equals to tab node dot next. Tab node dot get next. Okay, and then the tab node itself will be deleted. This is a bit more, what do you call it, developer friendly. You can understand this code better. Okay, so when we want to pop, list dot pop, list dot pop, and we display again, what we will get? We will get 10. So we are popping 30 and 20 from the list. Now let us do enqueue and dequeue. So we already have enqueue here. So let us just put list.enqueue. So let us do 15. Oops. Copy. And this one 20. And another one 25. Why not? Okay. So what we will get? We will get another 25, 20, and 15 and 10. So we are adding from the beginning. Okay, the push and pop, the push and enqueue is from the same direction. Okay, so before we proceed to the DQ, is there any question? We have around 40 minutes, more or less.
No, brother.
No, brother? No, brother. Okay, no problem.
No.
Okay, so we already done with the push, we have done enqueue, we have done pop. Now we are going to do DQ. DQ is a bit challenging because it requires you to go to the other end of the list. So what we are going to do first, as usual, we can just do it like this. If self hit is none, print list is empty. Else, what we can do, tab node equals, let's do current previous. Else, tab node equals self hit as usual, because we want to remove the last one. We have to have the previous one. So let us change this temp node into previous node and current node equals to previous dot get next. Okay. If current is none, okay, this is challenging. Okay, the idea here, let us return back here, is that since this, so we have the header. So the trivial case is where the list is empty. So we just return the list is empty when we want to do the DQ. Second is that what if the list has only one link, one node. So header, and we have node 1. Okay, and there's no other nodes. So if the next node is empty, okay, I think let's do this. Oops. I'm recording, right? Okay. So if it is only one node, not one node. If it's only one node, we can just pop it because basically the same thing. So pop, basically same as pop. But if there's more than one, actually we can do it like this: and 2 and 1 and 2. So what do we do? We have to declare 2 nodes. Okay, the previous node and the current node. Why? Because if let's say the next node, okay, what we are going to do is we are checking if the current node is empty. Okay, basically we are going to return to number 2. We are going to wait. Let me get my logic straight first. This is challenging. Let's know. If the next node, if we don't have any next node, then we remove the current node, so the previous node is linked to nothing. Do you get me? So in other words, we have current, we have next. If the next, so let me explain it slowly so that you guys can understand. If the next node is gone, meaning that we have reached the end of the list, what we are going to do is that we want to tell the previous node to detach current node from it. So we want to remove the current node from the previous node. But to check whether that current node is the last node, we have to check if there is the next node. Do you get me? So we need at least 2 nodes, the previous node and the current node. Okay? So if the current dot get next is none, okay, meaning that this is basically the first case. So we just pop. Self.pop. Okay, because basically we are just removing one node. So removing it from both directions is still the same. However, else, while current dot get next is while current.next exists, okay, so as long as it is not the end of the line, the end of the list, okay, so what do we do? Previous equals to current, and current equals to current dot get next. In other words, we are going to shift. Where is it? Where's the whiteboard? We are going to shift the previous one to the current one. So in other words, this is going to be our new previous. The current node is going to be the previous node. The next node will be the current node, and we are going to check for the other next node. Okay. And if somehow the current dot get next is empty, meaning that we have no nodes after the current node, so what do we do? Previous dot set link to remove link. My bad. Previous dot remove link. Where is it? We have this. So previous dot remove link. Okay. And for the current, we are going to delete both previous and both current. Just for the sake of emptying the data. Okay, so let us check whether this is correct or not. List.dq and then list.displaylist. Bismillah. And see, we have got our list where we remove 10 and then we remove 15 from the list, and we are only left with 25 and 20. So that's it. That's all for the stack and queue. We have covered this demo in just 30 minutes. Is there any question? Are there any questions about stack and queue? All the other things is just like I mentioned, max value. I won't be teaching that. Minimum value also I won't be teaching that, because that's basically what you have learned during your early programming class. So it might be redundant unless you want me to teach you. That would be like I don't know. It's on you. But for the topic today, we have done. Is there any more questions?
May I know, is there any group taking something on Q and Stack? I don't think I post for Q and Stack this semester.
Mm-hmm.
So yeah, we're good to go.
Yeah, good to go.
It is just for them to implement the class implementation.
I see. I've searched a bit about the implementations of linked list, and there's actually a lot. So this is the magic word again. One of the use of linked list that I've searched in your daily use, I don't know. So first is that playlist. I know you like hearing songs using Spotify, or I don't know, maybe watching YouTube videos, and you put it in the playlist. So basically that playlist is what linked lists are used. They are used in the way that we are putting it in terms of linked lists. it's not specific for stack or queue, but it is on linked list where you can have a playlist of as big as you want. Meaning, I know some of you have like maybe in your Spotify, you put you like that video or you like that song so much, you just put the like, but you just press the like button and you put it inside the list, which now has like over 300 or 400 of songs with all different genres mixed up. Okay, so I know some of you have that. So that applies linked list. Okay, there are some other maybe not lesser practical applications. Not practical, I mean, like for example, if you want to add two ridiculously large numbers, okay, as you all know, the largest, if I'm not mistaken, the largest bit size that can be stored in a variable is oh, long unsigned long ull, which is about the size of it is about 2 to the power of 64. Is it 64 or 32? It has basically it stores 64 bytes of data. But somehow maybe some of you are crazy lunatics, or maybe you are doing some research on ridiculously large numbers. So sometimes traditional way of storing data is not good. So you have to implement linked lists where you have to store each of the what they call it, each of where you provide, in other words, you provide strings of numbers to a program, and that program is going to store the numbers in the form of linked lists. And you want to do like operations like multiplication or division or addition. So using elementary addition rules, but in linked list form, so you can do it. Actually, you can go up to, I don't know, probably let's see, you can add up to 100 numbers on with a very precise on a very accurate precision. So that's another one. Apa lagi? What's more? Yeah, that's the lesser practical, lesser use applications in your daily life lah. Okay. So, is there any questions?
No, sebab lesson macam just redirect lah. Tak tahu tanya apa sangat. Just
But
push and pop je.
it's just push and pop, NQ, DQ, and that's all. I mean,
Can I say something?
sure.
Push and pop, right? Do
Mm-mm.
you remember? Did any of you remember another methods to use in especially the stack aside push pop? We can do some few things, right? Some ABT. Adam, can you remember?
What?
Can you remember any of the methods or any ABT of stack and queue?
I know how to write in the paper. I don't know how to explain.
No, but just say it like he mentioned he just only implements push pop, right?
Yeah. Q
So
and you
what
check
else
if it's
can we
empty or
do?
not.
Yes,
Post
okay.
infix. Is it?
Okay, we can pack, right? Like top of the stack without pushing it out. Sorry, without popping it out. So all those things, I think.
I think I remember.
Yeah, whoever is taking the project, maybe they are going to implement. Yeah, there are some few ADT maybe, like they should check whether the stack is empty.
Mm-mm.
Okay, so if they want to pop out empty stack, that should throw an exception. Maybe the
Mm-mm.
stack is empty. I think you did that right now, right?
Yes. I think indirectly I implement it. It's like a, what do you call it? A safety measure, because
Yeah,
if you don't apply the condition where the list is empty, then there will be an error. So let me show you. So let's say we are commenting this, and we are going to do it like this. And let us just push, not push. This is Not push. This is not push. Not the pop one, because the pop one is very dangerous. Okay, so like this, and let us pop as much as we want. So when we do this, we will have an error because we pop more than the items that are inside the list. So there will be an error. That's why. So let's just remove this. However, I'm just showing you just the basics. You can go wild with linked lists. Like you have we have seen my coding, like all this not nonsense. It's just like weird stuff. Okay, we have add to start, add to end, we have clear the list, we have length, where you can find the length of the list. Push pop, you have learned that. DQ NQ DQ display list also done. Max, you have seen the code. I did not teach you, but you have seen the code. Mean, minimum, self, range optimize, which is basically you pick the minimum and the maximum and you find the difference between both of them. And then you have the total. If somehow you are dealing with a linked list of numbers, and average. And then you have the check sort. Check sort basically means you are checking whether the list is sorted or not. So we are not sorting the list, we are just checking whether it is sorted or not, like that. And then we have the sort increase, where we want to sort it in an increasing order. And then we have sort decrease, where we want to sort it in a decreasing order. And then there's find data. I think I've taught you this. Find data, get data, remove by index. And then there's if you notice that there's one particular challenge here, where I mentioned insert the data into a sorted list while keeping it sorted, increasing or decreasing. If the list is not sorted, abort the operation. So this is challenging actually, because you don't know whether the list you are checking is already sorted or not. Okay. So if you want to try, I might do it as a, you can call it like a mini project, a mini project. I mean, if you want, I can make it like a 5-point
Thinking of it
task.
for maybe because for this class,
Mm-mm.
possibly I think they have chosen their
Nah, so
title, graph traversal software, Hopman coding software,
mm-mm.
CBI-based learning, and 01 knapsack. So this may be for complete, what do you call it? Stack and queue,
Mm-hmm.
for maybe for learning. Yes, I want to use this for learning next semester. So I think I'm going to give it to other group in the class
Sure,
which
sure,
are
sure.
not in this lab.
Ah,
So I'm going to give them one of this stack
mm-hmm.
queue. Yes, stack and queue. So they will implement using both array and length.
Mm-hmm.
So I think that can be okay for them. So that's
Sure,
a mini
sure.
project for them.
Actually, I do want to propose, maybe not for this semester or next semester, maybe like the operations with long integers, where
Operation long integers. Okay,
uh-uh,
okay.
so in other words, uh they have to create a program where it can handle very large numbers, where that thing uses linked lists. So they have to learn how addition using linked list work, how multiplication using linked list work, how division
Okay.
works. But that will be a very heavy project lah for them. One of the heavy projects lah. Uh-uh.
Maybe next semester
Mm-mm.
I can bond maybe two groups together so they can do it in piece and then have it as a big
I
big
don't
project.
think it's not that hard that we need two groups, but we'll see. We'll see. Mm-mm. We'll see for that.
plus the generation we're breeding now, I don't know why they don't want coding.
Mm.
Uh,
Yeah, me too.
how does it feel? But people are like
Mm-mm.
advancing in coding unless you don't really want it. It's fun anyway if you take it
Mm-mm.
serious. Okay,
Okay,
good
so
to go.
I think that's all. For this one, I've seen. Yeah, for the next for the next for before we touch a bit about the next lesson. So I would like to remind you that the task one, I'm pretty sure only four groups are there in this semester. So I think all of you have submitted. So for task two, I'm going to check it right after this class, okay, right after this session. And I noticed that some of you WhatsApp me that I forgot to put your metric number inside there. So I'll be filling in that. I'll be adding your metric number. So what more? As so I think that's for the task that we have done. For the next class, uh, I'm pretty sure you have learned a bit about hash table, where basically you have to imagine that what if you are not using numbers as key. Like traditionally in array, you are using index, numerical index, like index 0, index 1, index 2, and up until index infinity as your index. But in this case, what happens if you don't want to use numbers as your index, you want to use keys instead. Like you want to use like maybe a string as your index. So this is where dictionary comes in. Okay, where you want to declare, okay, what in this dictionary, using this key you will get this data, using this key you get another data, using another key you get another data. Okay, so this is also fairly simple how do you call it, simple topic. Okay, where I don't know for you lah. For me, since I've done this every semesters, pretty much I've known the nooks and crannies about this topic. But yeah, it's pretty simple. There's nothing much of a difference. The only thing that you have to worry about is the hashing function, where if somehow you are setting a limited size of that array, a limited size of hash table, and you want to use and some places are filled up and some places are not. In other words, if a certain key is used the same twice in a particular dictionary, so what are you going to do? Are you going to change the key? Are you going to rehash it? So this is where it comes in. So we have the rehash function. There are several ways, I think, where we use either rehash functions, no, linear rehashing, quadratic rehashing, and also, if I'm not mistaken,
They know it, they have done it. When
they have done
collision
it right.
occurs, you remember,
Mm,
guys? When
mm,
collision occurs, what do we do? Either
mm.
you do linear probing or quadratic, or you do double hashing, even cocoa hashing also.
There's also like linked list hashing, if I'm not mistaken.
Yeah, separate
Mm-mm.
chaining.
Separate chaining. So
So
yeah, I'm just going to for the next lesson, I'm just going to teach you linear rehashing. I might go into the quadratic rehashing because I thought the method of quadratic rehashing is a bit different when I first read it, and then when I read it, it's just like this. Okay, but I'll talk. I might get into that. We have also get item. We have set put item and a set item. Basically, we are creating our own self-defined array. Like, look at this. 10, 15. I'm not sure if I can put. Let's see. Oh yeah, you can put. You can put. Okay. I forgot. You can put some random numbers here. for this one, since we are still dealing with numerical index, it's just that the numbers are not limited. So that's why it came to like this 2098. Although the size of the table is 7. Okay. So that's for the hash table. For binary tree, we will touch into that later. There's also recursions. Recursion is not in the syllabus, but I just put it there because why not? And then we have GI of the tick inter here and there. Update data. Demo tick inter. Let me run this. What is this? Oh, this is the stack and queue. Stack and queue. Okay. So that's all. Is there anything you want to ask? I mean, since you guys already learned this theoretically in your theory class, I don't think you have so many questions.
No question.
No question. No question? The others?
Yes. Actually, for the carry mark spreadsheet, can you make it to edit, because I have group members want to add their metric numbers.
Oh, please PM me. Please PM me. I make it view only because I do not believe you guys to. I'm afraid that some of you might tamper with the marks. So just
Be editable for
Okay.
student, no? They
Thank you,
shouldn't
brother.
be able to edit. Students should just be able to view their own marks. So basically,
but for the but for the for the
you can easily change your marks either intentionally or unintentionally. So it
So
should be view.
that's why I only put it on view only. So yeah.
So you give mark based on the because how do I say put it? My friend has put his name on the what on the repository at the GitHub, but he
Mm-hmm.
didn't put his metric number on the spreadsheet, the CAM spreadsheet.
I'll
So
check for
his
both.
mark. Oh, okay.
I'll check for
Thank you.
both. But if somehow I miss out, please tell me.
Okay. Thank you.
Okay. Because I'll just give mark based on what I get to see lah. Because sometimes I may overlook, because some of you did not put your metric number in the repository, and then when I check in the spreadsheets, it's kind of like a mess. So I don't know what to put inside the carry mark. So please, if you don't see your name in your group, please PM me. Okay?
Okay, brother. Thank you.
Okay, no problem.
Also, Azima, do you count for late submission? You give the time, right? Time-based submission, is it?
Yes. Basically in
Penalize late submission?
I did not penalize, but I would check for the marks. I would check again.
Oh, okay.
So that's
Yes,
basically
there
the
is a
penalty.
penalty for late submission.
Ah,
Yes.
because
It's part of the gist. Yes.
I see.
When you want to get a full mark, you submit on time.
Mm-mm.
Otherwise, if there is late submission, then there will be a penalty for that.
Mm-mm.
That's the normal thing.
So basically for how I operate is that I give you one week to submit,
Yeah, 1 week
okay,
is just good.
and then another week to recheck your submission. After that, I won't check again. Okay. So basically, I give you guys 2 weeks in total to check for your submission. After those 2 weeks, it's basic. I won't check it again. Whatever inside the spreadsheets is going to be finalized. Okay. I will repeat this again and again and again. Despite you guys being bored of me saying it, I will say it again because I know for sure that some of you might forget. I mean, we are humans. We are nurse and nurse. which come from insan, which basically forgetful. Okay, so I'm here to remind you again and again. So for this time, for task number 2, I will check for tonight, okay, and I will update the marks as soon as possible. So you guys have 1 week to check, to PM me and ask me what is wrong with your coding, okay. And then for the task 3, you have 1 week to submit first, and then another week to check your submission. Okay? Is that clear for you guys? Okay. But don't worry, since your task 1 is you get full marks, so we'll see for task 2 and task 3. Okay? Is there any more questions before we end our class? Let me just stop the recording first.